Hello everyone, I am Shubham from FOM Tech CSE. I welcome each one of you with a very big heart on my YouTube channel, Software Engineer Shubham Patil. In today's lesson, we are going to talking about the basic concept of data preprocessing under the guidance of Sandeep Thorat sir. So let's get started with our discussion. This is our today's agenda. First we will discuss about what is data preprocessing in machine learning. Second, we discuss about why do we need data preprocessing, what is the reason behind this, and third one is what are the steps involved in data preprocessing. So let's get started with our first discussion, data preprocessing in machine learning. So as we know how data is important in real world, so this is the first and the most important step to create a machine learning model and to get the better result. So data preprocessing is nothing but a process of preparing or creating the raw data and which is suitable for a machine learning model. Next, why do we need data preprocessing? As we know, the in real world data contains some noises in data, some missing values, missing attributes, some errors, some manual errors, human errors, like it may be unusable format and which cannot be directly used for the machine learning model. So due to this, our model will get or predict the wrong result and it will not work properly for predicting the better output. So to avoid this, we have to use the data preprocessing, or we need the data preprocessing, and these are the some tasks required for the data preprocessing. For cleaning the data, and that cleaner the data which is suitable for the making the machine learning model, and that model which also increase the accuracy and efficiency of the machine learning model. So this is the reason behind we need the data preprocessing. Now next is what are the steps involved in data preprocessing. There are 7 steps involved in data preprocessing. First one is getting the dataset. We will discuss each step in details in upcoming slides. So next is importing libraries. Third one, importing datasets. Fourth one, finding missing data. Fifth one, encoding categorical data. Sixth one, splitting dataset into training dataset and testing dataset. Seventh is the feature scaling. So let's get started with our first step, getting the dataset. So what is dataset? The basic definition of the dataset is nothing but a collection of different types of data which may be in different formats. To create a machine learning model, the first thing we required is a dataset, and that dataset as a machine learning model which completely works on a data. So data is very important before creating the machine learning model. Next, this is the definition of dataset. Collected data for particular problem in proper format known as the dataset. Dataset may be in a different format for different purposes, such as if you want to create a machine learning model for business purpose, then dataset will be different for the business, and the dataset required for the liver patient also different. So for example, image dataset in computer vision, and these some applications of that computer vision like medical imaging technology, face recognition system, autonomous vehicle. So all these data are different. Means each dataset is different from the another dataset. Next, how to use the datasets in our code. To use that dataset, we have to just put into a CSV file. It also need to use the HTML or XML files. CSV is nothing but comma separated values, and HTML is hypertext markup language. This is the first step. Next is importing libraries. So importing Python libraries for data preprocessing. To perform data preprocessing using Python, we need some import. We have to import some predefined Python libraries, and these are the specific libraries to perform specific jobs. And in data preprocessing, we are going to use 3 libraries. First one is a NumPy, second one is a matplotlib, and third one is a pandas. We will discuss one by one in upcoming slides. So first we will discuss about NumPy. So what is NumPy? NumPy is a open source numerical Python library, and which is used for the including any type of mathematical operation in the code. It will do the maths operation, and this is the fundamental package for scientific calculations in Python. This is very important, and this is the first library, and it supports to add large multidimensional arrays and matrices. So in Python we can import as in following command, like we can say import. This is import is the keyword. NumPy is also keyword. Import NumPy. We can use this up to this, no problem, but we are using this for the shortcut purpose. And this as is also keyword, and this is our alias name for NumPy. So you can import NumPy as nm or np, anything as is used for to create the duplicate name for the NumPy, or to create the alias name for the NumPy. Second library is matplotlib. Matplotlib used for the Python 2D library, and with this library we need to import the sub library as a pyplot, and this library is used to plot any type of charts in Python for the code. And the command for this library is import matplotlib, import matplotlib dot pyplot is a sub library as mpt. This is important, and this is the alias name as we discussed previous slide. This is alias name for this matplotlib library, matplotlib.pyplot library. Moving on to the next, third one library is pandas. Pandas stands for Python data analysis library, and this is last library in the data preprocessing, and it is one of the most famous Python library, and used for importing and managing the datasets. And this is the open source data manipulation analysis library. It will be imported as the same like previous. Import pandas as pd. Pd is a short name or alias name. This is important. This is the alias name. It is used for alias as for pandas. Moving on to the next, importing datasets. Third one is importing dataset. We need to import the datasets which we have collected for our machine learning model or machine learning project. But before importing the dataset, we need to set the current directory as a working directory. So these are the steps below. To set the working directory in Spider, we need to follow the below steps. Save the Python file in our directory which contains dataset. Go to the File Explorer option in Spider IDE and select the required directory. Click F5 button or Run option to execute the file. So these are the importing the datasets. It's very important. Next is finding missing data. Ways to handle the missing data is below. There are only mainly two ways to handle missing data. By deleting the particular row, first way to use is to commonly deal with null values. In this way, we just delete the specific row or specific column, and which consists that null value. Next is it's not efficient in removing data, but may lead to the loss of information, will not give an accurate output. By deleting the particular row, we will not give accurate output. So, and next is by calculating the mean. In this way, we calculate the mean of the column or row which contains any missing values. We'll put in place of the missing value. This strategy is used only for the numeric data, because mean is calculating for the numerical only. Age, salary, year. This is the numeral data. For the other data is not possible to calculate the mean. Next is, so this you can see this. This is age and this is salary. For these two columns only we can calculate the mean, not for the purchased, not for the country. Getting this point? Moving on to the next. Encoding categorical data. Category. In previous slide we see the country and purchased. That is meant by category. Numerical means age and salary, like this. So categorical data is the data which has some categories, such as in our data sets there are two categories. We saw this: country, purchased. In this here, these two: country, purchased. Next is, since machine learning model completely works on the mathematics and numbers, so category means in the sense some data about in string format, some data in a string format, and our dataset would have categorical variable. It may create trouble, it may create some problem while building the model. So it's necessary to encode these categorical variables into numbers. So we have to convert categorical variable into numbers. So due to this we will calculate the mean and all other things. Next is split the datasets into training dataset and testing dataset. In the machine learning model, data pre-processing, we divide our dataset training dataset and testing dataset. And this is the one of the crucial steps in data preprocessing, and it will increase the performance of our machine learning model. So you can see the below picture. This is our dataset. We divide the dataset into training dataset and testing dataset. Suppose this data is 80%, this data is 20%. So we will train our model. We more the trained model, will get the accurate results while testing the model. So training dataset is a bigger as compared to the testing datasets, because model our trained, it will increase the performance. Next, this is the definition of the training set. This is a subset of dataset to train the machine learning model, and the output is already known. And this testing is, we have to predict the output of that model, and this is a testing dataset, is a subset of that to test the machine learning model. Next, if we given the training to our machine learning model by the dataset, we test it by completely different dataset. It will create difficulties for our model to understand the correlation between the models. If we train our model very well, its training accuracy is also very high, but we provide the new dataset, then it will decrease the performance. So we always try to make machine learning model which performs well with the training dataset and also with the testing datasets. So it will never decrease the performance if we try to make the machine learning model well. Next is feature scaling. This is the last step of the data preprocessing in machine learning. This is the technique to standardize and independent variables of the datasets in specific range. In feature scaling, we put our variables into same range and in the same scale, same range and the same scale, so that no or any other variable dominate the other variable. No one can dominate other variable if you put the variables in the same range and same scale. So the term is feature scaling. Next is technique to perform feature scaling. Consider the two most important ones, standardization and normalization. First is the normalization, min-max. Its techniques that rescale the feature or the observation value with the distribution value 0 and 1. This is the distribution value 0 and 1. This is the formula to calculate the feature scaling, normalization. Next is standardization. It's very effective technique to rescale feature value, which are distribution value 0 with 0 mean value and variance equals to 1. This is the formula for feature scaling, standardization. This is the dataset. As we know, this is our dataset. Feature scale. Next, it's we can see the age and salary column values are not on the same scale. See this, age and salary column not on the same scale. Machine learning model is based on Euclidean distance, and if you do not scale the variable, it will cause some issue. If you not scale any variable, it will cause some issues in our machine learning model. So I'm signing off the day. Thank you so much for your precious time. Take care. Bye bye.